In the crucible of the 1940s, humanity unlocked a power previously reserved for the stars. The invention of nuclear weapons marked a profound and, honestly, a terrifying turning point in our history. The devices used to end the Second World War, though devastating, were but a prelude to what would follow. In the decades that dawned after the war, a new and far more formidable type of weapon emerged: the thermonuclear, or hydrogen, bomb. This was not merely an escalation, it was a quantum leap into a new realm of destructive potential, one that absolutely dwarfed the atomic age's first creations. The sheer scale of these post-war devices is, well, difficult for the human mind to truly comprehend. We speak of yields in megatons, each unit equivalent to 1 million tons of TNT. Tests like Castle Bravo, which unexpectedly unleashed 15 megatons of force, and the colossal Tsar Bomba, a staggering 58 megaton monster, demonstrated a power that could alter landscapes, poison ecosystems, and cast a shadow of existential threat over the entire planet. These were not just weapons, they were geological events, man-made cataclysms that burned with the fury of a captive sun. We have gathered rare and declassified footage to bear witness to these moments. These are not merely historical records, they are stark reminders of the precipice upon which our species once stood, and the awesome, terrible beauty of a power we can scarcely control. The mushroom clouds that bloomed in remote corners of our world were monuments to human ingenuity and, perhaps, to our folly. Here are the 5 largest nuclear tests ever caught on camera. Our journey begins in the remote Pacific, at the Eniwetok Atoll in the Marshall Islands. It is the 1st of November, 1952. Here, the United States prepared to cross a monumental threshold. The goal was Operation Ivy, and its centerpiece was a device codenamed Mike. This was not just another atomic bomb, it was the world's first true thermonuclear device, a hydrogen bomb. It was an experiment to see if a fusion reaction, the same process that powers our sun, could be ignited on Earth. The device itself was a behemoth, a piece of industrial architecture rather than a weapon. Standing over 2 stories tall and weighing more than 82 tons, it was a complex assembly of cryogenics and nuclear physics, filled with liquid deuterium. It was so large and delicate that it could not be dropped from a plane. Instead, it was constructed within a massive cab on the small island of Elugalab, a tiny speck of coral and sand that was about to be erased from existence. At 7:15 in the morning local time, the device was detonated. The result was beyond anything witnessed before. A fireball, nearly 4 miles wide, erupted from the sea, vaporizing the island of Elugalab in an instant. It burned with a heat so intense it was as if a piece of the sun had been briefly brought to Earth. The light was blinding, a searing white that bleached the sky and sea, visible for hundreds of miles. The mushroom cloud that followed was a spectacle of terrifying proportions. It soared into the stratosphere, climbing to an altitude of over 135,000 feet, more than 25 miles high, within minutes. The cap of the cloud eventually spread out over 100 miles wide, a vast ethereal canopy of radioactive dust and superheated water vapor. It was a structure so vast it created its own weather system, a testament to the immense energy it had unleashed upon the atmosphere. The yield of Ivy Mike was calculated at 10.4 megatons. This was nearly 700 times more powerful than the bomb that destroyed Hiroshima. The force was so great that it did not simply create a crater, it carved a chasm into the ocean floor. The hole left behind was over a mile wide and deep enough to submerge a 17-story building. The island of Elugalab, along with parts of its neighboring islets, had simply vanished. The shock wave, a silent but powerful ripple of compressed air, traveled across the Pacific. It was felt on ships and islands hundreds of miles away, a physical jolt from an event happening over the horizon. The sound, a deep, guttural roar that followed minutes later, was described by observers as the sound of the world cracking apart. It was a primal, elemental noise that spoke of immense and violent change. The fallout from Ivy Mike was extensive. The vaporized island, now a cloud of highly radioactive particles, was carried by the winds. It contaminated a vast area of the Pacific, a stark warning of the unseen dangers of these new weapons. The test had been a success in the eyes of its creators. They had proven the concept of the hydrogen bomb. But in doing so, they had also unleashed a new kind of terror on the world. The footage captured that day is both hypnotic and horrifying. We see the initial flash, a silent, expanding sphere of pure energy. Then, the roiling, turbulent rise of the mushroom cloud, a living, breathing column of fire and smoke. It is a display of power on a scale that defies our everyday experience, a force of nature summoned by human hands. It is a moment frozen in time, a visual record of humanity's first step into the thermonuclear age. In the aftermath, scientists analyzed the debris and made a startling discovery. They found two new elements, einsteinium and fermium, forged in the intense heat and pressure of the explosion. It was a stark illustration of the extreme conditions created by the blast. Ivy Mike had not only reshaped a corner of the Earth, it had, for a fleeting moment, created conditions so extreme that they had forged new fundamental building blocks of the universe, right here on our planet. 2 years after the world was shaken by Ivy Mike, the United States returned to the Pacific, this time to Bikini Atoll. This was the stage for Operation Castle, a series of high-yield thermonuclear tests designed to refine and weaponize the hydrogen bomb. The goal was to create devices that were not just powerful, but deliverable. The era of stationary building-sized bombs was over. The age of airborne thermonuclear weapons was dawning, and this series would prove their terrible effectiveness. The second shot of this series, codenamed Castle Romeo, was scheduled for March 27, 1954. Unlike its predecessor, which had been detonated on an island, the Romeo device was placed on a barge, anchored in the crater left by a previous test, the Bravo shot. This was a significant change. It was the first test of its kind to be conducted on water, a pragmatic decision born of a grim reality. The United States was simply running out of small islands to vaporize. The device, known as Runt-Y, was expected to yield around 4 megatons. However, the designers were still grappling with the complex physics of lithium deuteride fuel. As with other tests in this series, the actual result would prove to be a dramatic surprise. At dawn, the countdown reached 0, and the placid lagoon of Bikini Atoll was once again transformed into a vision of hell. The device detonated with a force of 11 megatons. This was nearly 3 times the expected yield. The fireball, a blistering sphere of incandescent plasma, swelled to a diameter of nearly 4.5 miles. It lit up the morning sky with a light brighter than 1,000 suns, painting the clouds in surreal shades of orange, red, and purple. The sheer thermal energy was immense, boiling the surrounding seawater and sending a massive plume of radioactive steam and debris hurtling into the sky. The resulting mushroom cloud was a thing of dreadful beauty. It climbed with astonishing speed, reaching its maximum altitude of 115,000 feet in a matter of minutes. The cloud was a churning, chaotic mass, its stem drawing up millions of tons of water and pulverized coral from the lagoon floor. This material, now intensely radioactive, would form the deadly fallout that would drift downwind for hundreds of miles. The images captured of the Castle Romeo shot are iconic. Filmed from various angles and distances, they show the raw, untamed power of the explosion. We see the barge, the tiny platform holding the device, simply cease to exist in a flash of white light. The shockwave is visible as it expands, a shimmering, transparent wall of force that flattens the surface of the ocean. It is a silent, visual scream of immense power. The unexpected power of the blast served as another stark lesson for the weapon designers. Their predictive models for this new generation of solid-fueled thermonuclear weapons were clearly inadequate. The science of creating artificial suns was proving to be a volatile and unpredictable art. Each test was a gamble, with the potential for consequences far beyond the confines of the designated test site. The name Romeo itself is a curious footnote. The tests in the Castle series were named after letters of the phonetic alphabet, but in a sequence that seems to have its own internal and now obscure logic. Bravo was first, then Romeo. This naming convention adds a strange, almost poetic layer to these acts of scientific destruction, a human touch on an inhuman scale of power. The legacy of Castle Romeo and the entire Operation Castle series is complex. It pushed the boundaries of weapon technology, leading to the compact, powerful warheads that would fill the arsenals of the Cold War. But it also left behind a poisoned paradise. Bikini Atoll, once a vibrant ecosystem, became a byword for nuclear contamination, its waters and lands rendered uninhabitable for generations. The test was a success, but the cost was etched into the very atoms of the atoll itself. Just over a month after the powerful Romeo shot, the testing at Bikini Atoll continued relentlessly. On the 5th of May, 1954, it was time for the 5th test in the Operation Castle series. This device was codenamed Yankee. Like its predecessor Romeo, it was a barge shot, detonated in the same crater in the lagoon. The weapon design was different though, an experimental device known as Jughead, and its performance was, once again, a subject of intense speculation. Initial predictions for the Castle Yankee device placed its yield somewhere between 6 and 10 megatons. It was another test of a dry fuel design, using lithium deuteride, but with a different isotopic enrichment than had been used in previous shots. The scientists and military observers gathered at their posts, some 20 miles away, prepared for another spectacular, yet hopefully predictable display of power. At the moment of detonation, it was immediately clear that this was another exceptionally powerful event. The explosion unleashed a torrent of energy that far surpassed the upper estimates. The final calculation placed the yield at a staggering 13.5 megatons, making it, at the time, the second largest nuclear explosion in history, surpassed only by the recent and infamous Castle Bravo test. The fireball once again tore a hole in the sky, expanding to over 4 miles in diameter. The thermal pulse was so intense that observers, even at a safe distance, could feel a wave of heat wash over them seconds after the flash. The mushroom cloud, fed by the vaporized water of the lagoon, ascended to a height of over 130,000 feet, its vast cap unfurled across the stratosphere, a toxic umbrella spreading over the Pacific. What made the Castle Yankee test particularly noteworthy, and honestly alarming, was not just its immense power, but the journey of its fallout. The radioactive cloud, composed of pulverized coral, fission products, and bomb debris, was caught in high-altitude winds. It began a long, silent journey eastward, drifting far beyond the designated danger zone that had been established around the atoll. The cloud's trajectory was tracked with a mixture of scientific curiosity and growing concern. The radioactive particles, invisible and deadly, traversed the entire Pacific Ocean. They remained at high altitude for days, carried by the powerful jet stream. The cloud's journey was a stark, global demonstration of how a single event in a remote location could have planetary consequences. Astonishingly, 4 days after the detonation, traces of radioactive fallout from Castle Yankee were detected thousands of miles away, in Mexico City. The delicate instruments of a research laboratory picked up the faint but unmistakable signature of the explosion. It was a sobering moment. A nuclear test in the middle of the Pacific had dusted a major metropolitan area, on another continent, with its radioactive breath. The incident highlighted a terrifying new reality of the thermonuclear age. There was no longer any truly remote place on Earth. The atmosphere connected everyone, and what was put into it in one location could, and would, eventually find its way to another. The concept of a contained, localized nuclear test was proving to be a dangerous fiction. The planet itself was the containment vessel. The footage of Castle Yankee is as awe-inspiring as the other tests in the series. The massive, roiling cloud, the brilliant flash, the sheer scale of the energy release. It is a familiar, yet no less shocking sight. But knowing the story of its trans-Pacific journey adds a new layer of menace. We are not just watching an explosion, we are watching the beginning of an invisible atmospheric contamination event, a silent poison being carried on the wind to unsuspecting populations thousands of miles away. We now arrive at the most powerful nuclear device ever detonated by the United States, and arguably, the most infamous test in history. It occurred on March 1, 1954, the very first test of Operation Castle. Codenamed Bravo, this device was meant to be the showpiece of the series, a demonstration of a new, solid-fueled shrimp design. It was placed in a shot cab on an artificial island built on a reef off Namu Island, at the edge of Bikini Atoll. The weapon designers had predicted a yield of approximately 6 megatons. This was already an immense figure, but what was about to happen would shatter all expectations and create an international incident. The core of the problem lay in the lithium deuteride, fuel. The designers had correctly calculated the reaction from the lithium-6 isotope, but they had incorrectly assumed that the more abundant lithium-7 isotope would be largely inert. They were catastrophically wrong. At 6:45 in the morning, Castle Bravo was detonated. In a fraction of a second, it was clear that something had gone terribly awry. The explosion was not 6 megatons, but an unbelievable 15 megatons, 2.5 times more powerful than anticipated. The inert lithium-7 had, under the extreme temperatures and neutron flux, undergone a fission reaction of its own, dramatically amplifying the bomb's power in a runaway chain reaction. The fireball was a monstrous 7 kilometers, or about 4.5 miles across. It vaporized the entire artificial island, the shot cab, and tons of the surrounding coral reef, sucking it all into a superheated vortex. Observers stationed in a bunker 20 miles away were hit by a severe shockwave and a wave of heat far more intense than anything they had prepared for. The sky was lit with an otherworldly glow, a celestial event brought to Earth. The mushroom cloud was a thing of nightmares. It climbed to 47,000 feet in just over a minute, eventually peaking at an altitude of 130,000 feet. The cap expanded to a horrifying diameter of over 62 miles in just 10 minutes. But the true horror was what the cloud contained. The unexpected yield and the vaporization of the coral reef created a colossal amount of highly radioactive fallout, far more than anyone had foreseen. This cloud of radioactive coral dust began to drift east, carried by unpredicted high-altitude winds. It descended upon the inhabited atolls of Rongelap and Uterik, whose residents had not been evacuated. They witnessed a strange white snow-like substance falling from the sky. The children, unaware of the danger, played in the radioactive ash. Within hours, the entire population began to suffer from acute radiation sickness. The fallout did not stop there. It also descended upon a Japanese fishing trawler, the Daigo Fukuryu Maru, or Lucky Dragon No. 5, which was operating just outside the declared danger zone. The 23 crew members were showered with the white ash. They too soon fell gravely ill, and one crew member, Kuboyama Aikichi, would later die from complications of radiation exposure. His death sparked an international outcry and a powerful anti-nuclear movement in Japan. The Castle Bravo incident was a diplomatic and humanitarian disaster. The United States had severely underestimated the power of its own weapon and had failed to account for the weather, leading to the contamination of inhabited islands and the irradiation of foreign nationals. It was a stark and public demonstration of the uncontrollable and far-reaching consequences of atmospheric nuclear testing. The declassified footage of Bravo is perhaps the most terrifying of all. The sheer speed and scale of the fireball's expansion are breathtaking. You can almost feel the runaway reaction unfolding on screen. It is a visual record of a scientific miscalculation with devastating human and environmental costs. Castle Bravo was a line crossed, a moment when the abstract threat of nuclear weapons became a tangible, deadly reality for innocent people far from the blast zone. Our final destination takes us far from the warm waters of the Pacific to the frigid, desolate expanse of the Arctic. Here, over the Novaya Zemlya archipelago on October 30, 1961, the Soviet Union would conduct a test so colossal it remains to this day in a category of its own. This was the detonation of the RDS-220, known to the world, quite fittingly, as the Tsar Bomba, or the King of Bombs. This was not a weapon in the practical sense. It was a pure, unadulterated demonstration of power, a piece of political theater on a planetary scale. Conceived by a team of Soviet physicists under the direction of Andrei Sakharov, the bomb was designed with a potential yield of 100 megatons. It was a three-stage thermonuclear device, a design of terrifying efficiency. For the test, however, its yield was deliberately halved to around 50 to 58 megatons by replacing a uranium tamper with one made of lead, a measure taken to drastically reduce the amount of radioactive fallout. The bomb itself was immense, weighing 27 tons and measuring over 26 feet in length. It was too large to fit inside the bomb bay of any existing aircraft. A specially modified Tu-95 Victor bomber had its bomb bay doors and fuselage fuel tanks removed to accommodate the monstrous payload. On that fateful October morning, the bomber, painted a reflective white to offer some protection from the thermal flash, took off on its historic mission. The bomb was dropped from an altitude of 34,000 feet, attached to a massive parachute to slow its descent. This was crucial, as it gave the bomber and its accompanying observer plane just enough time, a mere 188 seconds, to fly approximately 30 miles away before detonation. The bomb exploded at a preset altitude of 13,000 feet above the ground, ensuring the fireball would not touch the Earth, a key factor in limiting the fallout. The result was simply apocalyptic. The fireball alone was 5 miles wide, It was so bright it was visible from nearly 620 miles away. A mushroom cloud, the likes of which the world had never seen, began to form. It soared to an altitude of 40 miles, piercing through the stratosphere and into the mesosphere. Its cap eventually spread to a width of 60 miles. The sheer scale is almost impossible to imagine. The effects on the ground, despite the airburst, were devastating. The uninhabited village of Severny, 34 miles from ground zero, was completely leveled. Buildings in districts hundreds of miles away were damaged. Windows were shattered as far away as Norway and Finland. The heat from the blast was so intense it could have caused third-degree burns at a distance of 62 miles. The atmospheric shock wave was powerful enough to be measurable even after circling the Earth 3 times. The crew of the Tu-95 Victor bomber experienced the blast firsthand. Despite their distance, the shock wave hit their aircraft, causing it to drop over half a mile in altitude before the pilot could regain control. The plane was fortunate to survive. They had looked back upon a spectacle that no human had ever witnessed. A man-made sun rising over the Arctic, a churning, incandescent sphere that seemed to consume the sky itself. The Tsar Bomba detonation was the single most powerful explosion ever initiated by humankind. The 58-megaton blast was equivalent to more than 3,800 Hiroshima bombs detonating at once. It represented about a quarter of the total explosive power of all conventional bombs dropped during World War II, unleashed in a single, blinding instant. It was the ultimate statement of the Cold War, a demonstration that the power to destroy the world was not just a theory, but a proven capability. Footage of the event, filmed from the observer plane, is grainy and remote, yet it conveys the unimaginable scale. The curvature of the Earth is visible, and against it, this colossal, growing entity of fire and cloud. It doesn't look like an explosion on Earth, but rather a cosmic event happening to Earth. It was a terrifyingly successful test, and it served its purpose. The world took notice, and the sheer horror of such power likely contributed to the signing of the 1963 Partial Test Ban Treaty, which prohibited atmospheric nuclear tests. The King of Bombs had made its point. The images we have seen today are more than just historical curiosities. They are echoes from a time when humanity wrestled with a power it could barely comprehend, let alone control. From the vaporized island of Elugalab to the globe-spanning shockwave of the Tsar Bomba, these tests represent the absolute zenith of our species' destructive capacity. They serve as a permanent, stark reminder of the responsibility that comes with scientific knowledge and the thin line we walk between innovation and annihilation. The mushroom cloud has become a universal symbol, a haunting icon of the 20th century, representing both a terrifying power and a profound warning. The era of large-scale atmospheric testing is, for now, behind us. Treaties born from the fear these very tests inspired have pushed such experiments underground, out of sight. Yet the weapons themselves remain, thousands of them, silent in their silos and submarines. The knowledge of how to build these suns on Earth has not been forgotten. These films, then, are a vital part of our collective memory, a lesson written in fire across the sky that we must never forget, lest we be doomed to witness it again, not as a test, but in earnest. Well, that's all we have for this video. If you enjoyed it and want to see more just like it, then be sure to click the link on screen now. Thanks for watching, and be sure to tune in next time.